I've created a repository in GitHub for the presentation that I'm giving today. The repository is available under my GitHub account, which you can see here in the website. It's a Bunwas, and the repo is manning twitch build deploy API. I've included a README file in the repo with some information about myself and also brief agenda of this presentation. So about myself, my name is Jose. I'm a full stack consultant based in London, and I am the creator of Microservices.io. Microservices.io is a website that allows you to easily mock an API in the cloud. Basically, you can mock an API with this tool, and this makes it easier for API client developers to build their clients against an API specification. This is what it looks like. So you would paste the specification here. Only works for REST APIs at the moment. You would paste the spec here, you click mock, and you get your mock server. I'm also the author of Microservice APIs with Python. This is a book published by Manning. The presentation is titled Building and Deploying Reliable APIs with FastAPI. So FastAPI is a API development framework for Python. Very popular at the moment. We're going to build a simple API with FastAPI. We're going to deploy the API to Heroku. We're going to set up also the continuous integration server with Travis. And the keyword here is reliable. So I'm going to show you a workflow that you can use to make sure that you deliver successful API integrations. And what do I mean by this is that when we build an API, we build it for other people to consume. So if you think of an API as a product, it's just a type of interface to service, and it's just like a website. It has an interface. All the people are going to consume this interface, and they expect the API. They need to have some expectations of how the API behaves, what it does, and what they can do with it, right? And our job as API developers is to deliver on these expectations and make sure that the API that we deliver complies with what our users are expecting. I'm going to show you one way to do this in this presentation. Briefly, the agenda, what I'm going to go through is, I just did the introduction. So the next step is I'm going to introduce the simple API that we're going to build in this exercise. Then we're going to build it with FastAPI. Then we are going to test it. And I'm going to show you one way of testing the API without you having to write a single test. And this is very useful because you won't have to spend any time writing validation tests for your API. There are tools and frameworks out there that can do this for you. They do it very well, probably much better than we could do if we were writing the tests ourselves. And it's going to help you speed up the development process and make sure that you don't take the wrong path. If you have some bugs in your API, all of these, you're gonna catch it early on, and you're gonna be able to fix it. We're gonna set up a continuous integration server with Travis, and we're gonna configure it to deploy to Heroku. The API that we're gonna build today, that's gonna be a simple to-do API. The specification is available in the repository that I prepared for this presentation. The repo at the moment is with the basic layout. It contains the basic files, no code yet. It contains a pip file with dependencies. It contains the README file that we went through before. It contains the OpenAPI specification for the API that we're going to build, and a package JSON with some libraries that I will comment later. This is a fresh repo. We're going to build the API on top of these files. So I'm going to show you with my development editor the API. The API is here. It's a very simple API for managing to-do items. Basically, it's going to allow us to create a task, to update or get the details of a task, and to delete the task. It's written in OpenAPI specification format version 3.0. The most recent version of OpenAPI is 3.1. If you can, you should be using that version. But this is an example that I have from a previous exercise, so just to avoid changing, it's using the previous version at the moment. Visualizing APIs in this kind of documents is not that easy. What I recommend is you get a proper visualizer. So I'm going to show you one here. It's Swagger. So there are different ways of visualizing REST APIs. Swagger is the classic, is one of the most popular still. Usually when I want to get a picture of what an API looks like, I go to Swagger's editor. So that is in editor.swagger.io. By default, it comes with the Swagger Pet Store, which is the classic example for REST APIs. We can paste here our API specification for the TODO API that I showed you before, and this updates the Swagger UI. So here it's very easy to see what the API actually looks like. So it has two URL paths. One is generic TODO for the generic resources representing a TODO item, and then we have specific resources targeting each specific task and what we can do with them. What happens here is so each URL path offers a bunch of endpoints. The get endpoint on the TODO URL allows us to get a list of items. The post TODO endpoint allows us to create a task. The task ID allows us to retrieve the details of a task. We can update the task with the put endpoint, and we can delete the task with the delete endpoint. Put is, so this is from the HTTP protocol. Put is not really an update method, it's a replacing method. So put is supposed to be idempotent. When you hit the endpoint, regardless of how many times you do it, it's always going to give you the same response. And what we're supposed to do with a put endpoint is we are supposed to send to the server a full representation of the resource that we want to update, and the server has to replace the representation of the resource with the payload that we are sending in the request. If we wanted to be able to update the resource based on be able to update the specific properties of the resource, we would be using a patch endpoint, but to keep things simple in this presentation, I'm just using put. We can see also there are a bunch of validation schemas for the API. So there is an error schema, which is just generic for representing errors whenever something goes wrong with a request. There is also a create task schema, and this is the representation of a task that is required when we send a task to the server to create it or to update it. We also have a get task schema, which is the schema that we can expect from the server when we get the details of a task. And we also have the list task schema, which is it tells us what the collection of tasks is going to look like when we hit the get to do endpoint. So this is about the API that we're going to build. It's very simple, but it contains all the ingredients that you're going to find usually when working with APIs. Let me introduce the tools that the frameworks libraries that we're going to use to build the API. So that is listed in the pip file. So we're going to be using, in this specific exercise, version 3.9 of Python, but really this will work with any version of Python upwards of 3.6. So if you want to use a different version of Python, that's fine. I'm not going to use any of the specific features of the latest releases. Then the cool packages of this application are FastAPI. That's the framework that we're going to use to build the API. It is Uvicon, which is the web execution framework that we're going to use to run the server. And then there are a couple of dev packages. One of them is called Dredd hooks, and I'll talk about this package a little bit later in more detail when I talk about the test framework we're going to use to test and validate the API. The other one we have here is Data Model Code Generator. Now, this is a package that is going to allow us to generate the schemas from the API specification directly into code. So we don't have to write any code to implement that part of the API. And that's really neat and really useful. And it's also one of the parts where we tend to make more mistakes when working with APIs. So it's really useful to use one of these libraries to get this done. Let me introduce each of these libraries in a little bit more detail if you're not familiar with them. So FastAPI is a really popular API development framework in the Python community right now. It's has the selling point of being highly performant. It's very fast and reliable. It's a little bit different from what we are used to with Flask and Django, and it is more performant, or it can be more performant for a couple of reasons. One of them is it's built on top of a Starlet. Starlet is mentioned here in the README. So Starlet is it's an asynchronous server implementation in Python. A big asynchronous has advantages in the context of web servers, because if you think about it, a web server is mostly all about I/O operations. We have incoming requests over a socket, and we are responding to them. And typically we have also connections with the database. When a request comes to the server, then at some point we fetch some data from the database, and during the time that we're fetching that data, there's an advantage in being asynchronous in that the execution framework, while a specific job is waiting for data to come from the database, can put that job to sleep and take care of all the tasks that require attention from the execution framework in the server. That's how we gain a little bit of speed with FastAPI. But also, it's faster because of Pydantic. Pydantic is a highly optimized data validation library for Python, and that's the part that helps us to validate and serialize data in the API. If you are not familiar with Pydantic, it's very neat. You can use it for anything that requires data parsing, validation, and things like that, not just in the context of web servers, but also in the context of configuration parsing, data exchange across different components of a system, and things like that. It uses type hints to define the validation rules of our data. It's very elegant, it's neat, and it's also, with the increasing use of type hints in Python, it feels more Pythonic than what you can find in more traditional frameworks to data validation. That's a few words about Pydantic and FastAPI. We're not going to create our data validation models in Pydantic manually. We're going to use data codes. How was the name? Data model code generator. So let me show you how we do that in the first place. What I have here is the fresh repo, as you can see it also in GitHub. First of all, let me create a folder to contain the code for the API. So that's because the API is to-do, it's a to-do service. Let's call the folder to-do. Within to-do, we're gonna have the files of the application. I'm gonna keep it simple for this presentation, but typically what I would do is within to-do, I would create a folder which contains the web server API layer implementation, and in a different folder I would have the core of the service implementation. And this is following the idea of hexagonal architecture. If you're not familiar with the concept, it's one of the best concepts of software development, like in terms of software architecture. So if you Google that, you can read this article from Wikipedia to get familiar with it. I also talk about this concept in my book, and I show you how you can apply this concept to building your microservices. The basic idea is, like you can see in the image here, there's a core to the application logic that we implement, the service, right? That's the part of the code that implements the capabilities of our service. And then everything else, everything that like implies the code, talking to all the things external to the code, that comes in the form of ports and adapters. So if you think of interfaces, how we interface with the core application logic, so we can do that through a web API, but we can do it with other types of interfaces as well. Like it's listed here, we could have a CLI, we can have a UI, obviously we can have an API as well, and that would go, if I was building my service in that way, I would put it in a different folder with all the utilities and implementations that go with each of these layers, each of these interfaces. And then if we have part of the code that needs to talk to a database, we have another module or folder for that. And then we would have connectors to databases, to queues, streams, files, cache servers, and whatnot. And the idea of this is it helps us to implement our application towards interfaces and to have less reliance on the specific implementation details of each of these layers that are connecting with the core of the application. Now we're not gonna do that here. Let's keep it simple. I'm just gonna have one folder for the API. It's gonna contain all the folders that we need to run the server. We're not gonna have databases or anything. We're gonna keep it simple. And but yeah, if you wanted to make it better, use something like hexagonal architecture to decouple your layers and your components. First thing we want to do is to install the dependencies. We use pipn for that. If you don't have pipn installed, you can install it with pip. So it will be pip install pipenv like this. I'm not going to do that now because I already have it. So I'm just going to install the dependencies. That you do it with pipenv install. Okay, actually I just realized I made a mistake because we have some dev dependencies like I showed before here in the pip file. We should be running it with the dev flag so that we get the dev dependencies installed. So let me do that again. Again, everything a little bit slow, nearly there. Okay, so we have the dependencies. Now we activate the environment, and we do that with pipenv shell. Okay, so that is the environment activated. We should have all the dependencies in place that we need. I don't think anything has changed here. The repository already contains pipenv log file, so it's ensuring that if you install from this repository, you install the exact same dependencies that I'm running in this exercise. Like I said, we're going to use a tool to generate the Pydantic model. So let's go ahead and do that. I think I ran this before. So the command is like this: data model called gen. We need to give to this command the input file that we want to use to generate the schemas. So that's basically the path to the API specification, and we need to give it the path to the file where we want to have the Pydantic models generated. So like I said, we're going to keep it simple in this case. So it's going to be just a schemas file under the to-do folder. So let's go ahead and run this. Okay, that was fast. Now that is available here in this file. Let me make this bigger so that you can see better. So this file contains a few details about how we generated the file. So it gives us the path to the file that we use to create these Pydantic models, and also the timestamp of when we ran the when we created this file. Data model code generator does a pretty good job at creating the Pydantic models from our API specification. Sometimes there are a couple of things that work a little bit different in Pydantic with regards to OpenAPI. And there are a couple of things which are going to change because of that. So if you see, we've got the error schema, which we had in the API. That's good. We've got the create schema, create task schema as well, and we've got the get task schema and the list task schema. So all of that is good. The only thing we don't like so much is the duplicated code around here. So these are enumerations. Enumerations are properties of an object that take on a constrained number of values. In this case, we have enumerations for the priority task, the priority property of a task. We want to make sure that only represents one of these three values, low, medium, or high. And we also have an enumeration for the status property of the task. So it can only be pending, completed, or in progress. In the OpenAPI specification file that is here, if we go to this schema, the enumeration is embedded in the definition of the schema. So we don't have an external object that represents the enumeration. Now, Pydantic doesn't do it that way. Pydantic has an external object, an independent object that represents the enumeration, and then it uses this enumeration in the definition of these properties. That's fine. The only problem is in this specific case, because the priority and the status properties are duplicated in two schemas, we are getting duplicated enumerations as well. So what we want to do is delete. We want to delete these classes, and we want to change the pointers here so that they point to the same classes here, and that makes sure will ensure if we ever make some changes to these classes later in the future, the changes will apply both to create task and get task. So we don't have to duplicate any of our efforts. So that is the Pydantic models. Let's go ahead and start building the API itself. So first thing we're gonna do is we are going to create a server file. This file is going to contain an instance of the server, of the API itself. It's going to be the entry point to the API, and then we're going to create another file called TODO. It's going to be API.py, and API is going to contain our view functions. So we're going to implement the endpoints of the API in this file. One thing I would like to say is I have two branches in this repo. So one of them is master and the other one is test. So I've been testing this before, the presentation, to make sure everything works fine. So the whole code implementation is in test at the moment. I will promote this to master later, and you will be able to see the implementation in master maybe tomorrow when I find the time to put it in master. Meanwhile, let's go back to master. Okay, let's start creating the entry point for the app. That is going to be in the server file. Let me make it bigger so that you can see. And so to create the entry point, if you have experience with Flask, this is very FastAPI offers an interface which is similar to Flask. What we are going to call here the server is the classic application object in the context of Flask. This application or server object is going to give us decorators that we can use to create the endpoints of the API. So let's go ahead and import the FastAPI class. So from FastAPI, import FastAPI. And then to create an instance of the server, we simply need to say server equals FastAPI. Okay, so that's the instance of our server. That's the entry point into the API. This is the server object. This gives us the decorators that we can use to create the API views and all of that. But we have to load those views as well to make them available to the server when we start up the server. For that, we can use different approaches. I'm going to use a simple approach here, which is importing directly the file. This is going to load the API module at load time. And it's going to make the API views it's going to register the API views with the server object on a startup time, and that's going to do the job in this case. We're going to say we run the server in debug mode. Right. Missing a keyword here. Okay, so this is the entry point to the app. Now let's go ahead and start implementing the endpoints. So first thing, like I said before, I'm not going to use a database here. That would be it will make the presentation a little bit more complex and a little bit longer. So to keep it brief and simple, we're gonna store the items in memory list. So that's gonna be todo equals a Python list. We're gonna put the items in this list. We're gonna delete them from this list, and it's just gonna work that way. If you're building something for production, we want to persist our data in a database or something similar, but we're gonna keep it simple in this case. And now let's start building the endpoints. So let's go ahead and do the simplest one, which is the get to do endpoint. So to do that, we're gonna use the get decorator on the server object. Let's import that. So that is the server variable. The first argument to the decorator, first one word in this method. This is directly the HTTP endpoint of the URL path. So FastAPI exposes, allows like every HTTP method through the object. So we're gonna have get, post, put, patch, delete. Probably there is options as well. Any method that we need. Then the first argument for this method or function is the URL path where we want to register the method. The second important argument we want to give it here is the response model. So that is response model. That is the pedantic class that FastAPI has to use to validate the data and to serialize it. So that is going to be list tasks schema, and let's import it. Right. So, and as I said that, another clarification is, so when we have an API, we want to make sure that any data that is sent by a user is validated. That for sure we have to do. But there is also the possibility of validating data that we send to the user. And There are different approaches to this. Sometimes people prefer not to validate data. There are good arguments for both approaches. So if we don't validate the data, there is the assumption that any data which is sent by the server is supposed to be correct. In my case, I prefer not to make many assumptions. So as much validation as we can have, I prefer to have it, because we could have some error in the, like some field that has the wrong name in the database, or it gets the wrong translation in the API, like in the application logic, and we want to make sure that this is validated before we get it to the user. Otherwise, we run into these problems of maybe not delivering to the expectations of the client of the API. So FastAPI is going to perform validation both sides, for data coming in and for data going out. Now, this is a decorator. We need to name the function that implements the get endpoint, and we're going to call it get tasks. We call it like that because this is really what it does. We are just sending the list of tasks. And what we're going to do is return a dictionary that represents the payload for this endpoint. So if we go back to Pydantic, well, not Pydantic, but the schemas file, we see list task schema has a task property which points to a list of tasks, and that's exactly what we do here in plural. And to do is holding the list of tasks. We're going to store it as dictionaries, but FastAPI knows how to serialize those dictionaries into JSON objects to send them to the user. Now we already have an endpoint. At this point, we can run the server already and see what it's looking like. To run the server, like I said before, we're going to use uvcon, and to get it started, we do uvcon. And we need to give the path to the object that represents the server. So that is to do. Within to do folder, we have server file, and within the server file, we have the server variable, which represents the server. Let's run this in reload mode so that any changes we make to the files can be picked up by Unicorn and refreshed. So it picks up the changes to the files. So let's do it that way. So now the server is running on this address. Let's copy this and paste it in the... Anyways, that's the URL for our server. Now, the naked URL doesn't have... it's not something we have defined in the server. Typically, if this was a proper website, this would give you the UI perhaps. We don't have such a thing. We're just building the API, so we don't have anything. If we hit the to-do endpoint, we did implement the get to-do endpoint, so we get an empty list of tasks because we haven't created anything else at the moment. The interesting thing about FastAPI is it can also create a Swagger UI from the code. So if we go to the docs endpoint, we get a Swagger UI, and this allows us to interact with the API. So we can click here to try the method, we can execute, and this is talking to the server right now, and we're getting an empty list of tasks like we did before when we hit the endpoint directly in the URL. Right, so this is for one of the endpoints. Let's go ahead and implement the rest of the endpoints. Let's go with the post endpoint. This is also on the to-do URL. The response model is get task schema. Something else here that we want to do is, if you see the specification, post has 201 response status code, and we want to specify that here. So by default, FastAPI will send 200 responses to the client. If we have a different type of response, we need to specify that here in the arguments to the decorator. So that's going to be status code. That is status HTTP 201 created, and that status comes from Starlet. Okay, something here, HTTP 201 like that. Okay, now let's give it a name to this method. We're gonna call it create task, and it's because this is a create method. It takes a payload. We capture the payload through the arguments of this function. So the payload we specify like this. We put a type hint pointing to the Pydantic model that validates the incoming payload. So that is create task schema. We need to import it as well. And what we are going to do is get the dictionary out of this object. This is going to be an instance of a Pydantic model. So we want to say payload dict. We want to populate the task with any missing attributes that the user hasn't added. So if we go back to the specification here in create a schema, we see the only required property of this schema is task. The priority and the status are optional. So we're going to add those. We're going to add default values for those properties. If actually they already come with default values, we're going to just going to capture them from the payload, because Pydantic is adding the default values. If we see in the these properties are getting default values, so the object is going to come with those values already. So we don't need to add that here. The only thing we need to add is the created property and the ID property. Those things need to be created in the server. So let's go ahead and do that. That is a UID. We're also going to do the created field, and that's a date time. Date time. Now, now to have a string representation of the enumerations, we need to capture the value of the enumeration. So that is in the task status value, and then task priority is the task priority value. Then we add this to the in-memory list of tasks. So we add the task here, and then we return the dictionary representation of the task with the properties that were added in the server. So the ID and the created property are set in the server. Everything else is coming from the user and or is added by Pydantic by inspecting the schemas and figuring out which attributes have default values if they haven't been set by the user. A little bit quickly to make sure I don't hold you here too long, I'm gonna just copy paste the get to do with the task ID endpoint. We need to import this as well. Not like that. Well, yeah, that's fine. For those endpoints which are trying to retrieve a specific item, it's possible that the item requested by the user doesn't exist. And in that case, we have to respond with a 404 response saying that the item doesn't exist or couldn't be found. So to do that, we do it by raising an exception like this, specifying the status code of the exception and the error message passed as the detail of the exception. That again is part of the API specification here. So in the put endpoint, for example, has 404 response here if the item is not found. Let me put here quickly the implementation for the put endpoint. This again is complaining, and let me do the one for delete. So the status code again is different. Here it's going to be a 204. So that is status HTTP 204. We're going to leave it like this for now, and this is delete task. We get the task ID. We capture it from the URL. The type of this is a UID, so we put it like that. And what we do is we say for index task, we iterate the to-do list. and we say if task ID is equal to the task ID given by the user, then to do pop, we're going to delete the task by the index, okay? And then we return. So true or false gives you empty responses. This is from the HTTP protocol. It's not expected to return any kind of payload, so we just return empty. This is by default is none, but we're expecting the framework to translate this into an empty payload. And then if it isn't found, we raise the same exception that as we are doing with the other endpoints. So that goes here. Okay. Now we can test it. We were running this with reloading enabled, so all the changes will be reflected in the API if we reload this. So these are all of the endpoints. If we try the post endpoint and we create a task, that is fine. If we get the list of tasks now, we get now one task. We can also validate this like we did before, directly with the talking directly to the API. So this should be 8,000 to do. But here we have the task that was created before. So that's beautiful.